Dear students, welcome to the video lecture of algorithms. Algorithm is a step-by-step method of solving a problem. An algorithm is a detailed series of instructions for carrying out an operation or solving a problem. It is a detailed series of instructions for carrying out an operation or solving a problem. Algorithm representation. The first one is step form. Solving a problem is stated with a written statement, natural language used in the step form. Pseudocode is a combination of programming language and natural language. Programs are written in the form. The program is a written form representation of the algorithm. Pseudocode is a written form representation of the algorithm. It is different from the step form as it uses as a restricted set of vocabulary to define its action of solving a problem. So it's very easy to convert a pseudocode into a program, okay, because it is having a restricted set of vocabulary. And the flowchart and Nazi-Schneiderman are the two different methods. They are the graphical representation. Okay, the problem is represented graphically. Characteristics of a good algorithm. First one is precision. The steps are precisely stated. Okay, defined. Every step should be precisely stated or defined. Uniqueness. Result of each steps are uniquely defined and only depend on the input and the result of the preceding steps. Finiteness. The algorithm stops after a finite number of instructions are executed. Okay, algorithm will not so lengthy. It should contain the finite number of instruction. Input. The algorithm should receive the input. Output. The algorithm produces the output. Generality. The algorithm applies to set of inputs, that is test cases. Then actually pseudocode, we can say that pseudocode is a algorithm representation method which contain the rich set of we can say this is very restricted vocabulary. We cannot use so many things. Okay, for example, when it is a written statement and written form of algorithm, no, it is very easy. If we have a step form algorithm, we can use our natural language, but here in pseudocode form we have to use the restricted set of vocabulary which is defined for this purpose. The keywords are for receiving an input. Okay, read, obtain, get are the keywords for receiving an input. Output to produce the output. Print and write are the keywords to produce is the output. Okay, to represent the output. Compute to perform a computation, we have to use compute, calculate, determine. We can use any one of the keyword. Initialize the value to a variable. For example, you want there's a variable a, you want to initialize it to the zero, then you have to give a set or initialize. Okay, are the keyword. And one. For example, you have a variable a which is having a value 10. You want to increase it, you have to use the keyword increment. Subtract the value of the variable, you have to use the keyword decrement. So these are all known as a keywords. Operators used in the algorithm. So this is a symbol, the left arrow symbol. Arithmetic operators are assignment operator, left arrow symbol, plus for addition, minus for subtraction, star for multiplication, slash for division. And the relational operators, these are arithmetic operators, relational operators are the following relational operators are used. Greater than, less than, equal to. The symbol, the symbol is stands for the greater than symbol, and less than, double equal to symbol is first stands for equality, greater than equal to, not equal to are the relational operators used in the algorithm. The logical operators are and or not are the logical operators which are used in the algorithm. Key features of the algorithm is, okay, we are having a three kind of structure. First one is a sequential structure of the algorithm. Sequential structure algorithm represented is a step-by-step manner. Sequence means that each step or process in algorithm is executed in a specified order: action 1, action 2, up to action, and this is known as a sequence. Next one is conditional. If algorithm's outcome of a decision is either true or false, is known as a condition. There is no state in between the if condition in between. Okay, only we are having a true or we have false. If condition is true, then the statement in the if block will get executed. Otherwise, the statement in the else block will get executed. If condition is true, no, the statement under the if block will get executed. If condition is false, the statement under the else block will get executed. This is known as a conditional structure. Next one is a repetition structure. Repeat the set of statement until the condition is true. So repeat until the condition. You have to repeat the statement until the condition is true. So repeat until condition. Okay, in repeat. Okay, the set of statement will get executed until the condition is true. Repetition can be implemented using a construct like repeat loop, while loop, if then go to loop. It will repeat the statement until the condition is true. Some other features are of the algorithm. Algorithm to be terminated with the correct answer. Okay, when algorithm exists, algorithm should produce a correct answer. Correctness means how easily its logic can be argued to meet the algorithm's primary goal. Correctness is a degree to which algorithm performs its specific function is known as a correctness. Variable is a we can say storage. It is a, we can say that it is a container. Every algorithm contains data. Usually, data is contained in what is called a variable. Okay, variable is a container for a data. We can say variable is a container for a actually a value of a particular data type. Variable is a container for a value that may vary during the execution of the program. Variable and data types. Okay, numerical data 12, 11.45901 are the numerical data. Alphabetical character data such as A, Z, and this is alphabetical. This is a character. These are known as a character and string data. Logical data that is proportional to true or false value. Logical data will take the value of true or false. Next, we have to discuss about the important one, subroutine. Subroutine, that is very important concept in the algorithm. So see that the first one, a structure is a simple program. So for start, statement 1, statement 2, statement 3, statement 4, and end statement will get executed one by one. The algorithm reaches the end state. Next, structure of a program with the repeated procedures. Okay, we are having a statement 1, and the start, statement 1, and procedure X. Okay, set of code. Okay, and statement 2 and procedure X. Okay, the procedure twice, the procedure same code is repeated. X is repeated twice in the program. It's a duplication of the code. Okay, the procedure X is code is given here and repeated here also, and up to statement 1. The next is a structure of program using subroutine. So this is known as a subroutine. Subroutine means a procedure X is separately defined as subroutine. Whenever the code is needed, it will be called. So procedure X is written only once. So statement 1 calls the subroutine. Okay, before the execution, after the execution, it will control returns to statement 2. Next, the statement 3 will get executed. It calls the procedures X as a subroutine, and again after the execution, it reaches the statement 4. So in this case, what happens? The procedure is written only once as a subroutine. Whenever a statement requires the procedure, it will be called. So there is no duplication of the call here. So the solid line stands for a call, dashed line stands for the return. So this explanation is given here. So three constructs, as we discussed, the three constructs of the algorithm. Sequence means we are having a set of statements. So after the execution of action 1, action 2 will get executed, then action n, okay, it will go continuously. This is known as a sequence. If condition, then the second one is decision. If condition is true, then if block will get executed. Otherwise, else block will get executed. So if, then, else, and end if can represent, we can also represent like this. So repeat condition or while and loop is known as a while condition end while. That means that until the condition is true, the state of statement will get executed. This is known as a repetition. Okay, this is like a repeat until only. We will see some example. For example, one, a sequential. So there's a program is write an algorithm to add two numbers entered by the user. Okay, we have to write algorithm to add two numbers which is entered by the user. Step 1, start. Step 2, declare a variable num1, num2, and sum. So three variables are declared. Third, read the values num1 and num2. So read the values means, okay, for a variable num1, num2, you have to read the value from the user. Add num1 and num2, you have to add the two variables and assign the result to the sum. So sum equal to num1 plus num2. Okay, then display sum. So sum will get displayed. So finally, step 6 for stop. The algorithm gets stopped. Okay, so two values obtained from the user, they are stored in the num1 and num2. They are added, and the result is stored in the variable sum. Sum will get displayed, and algorithm stops here. Second is an example for the conditional statement. Write an algorithm to find the largest among the two different numbers entered by the user. So largest of the given two numbers. This is under, we can write the code under conditional structure. Start, declare a variable A and B. We have declared two variables, that is A and B. Read the variables A and B. A and B should get read. If A greater than B, the condition is true, display A is the largest number. Else, okay, display B is the largest number. If condition is true, then A is largest number. Else B is largest number. It means that you are getting a value for A is 10 and B is 20. B is 5 means 10 greater than 5. So display A is the larger number is get displayed. For example, if you have a value for a equal to 5, b equal to 10 means a greater than b is false. On the time display, b is the largest number will get displayed. Next, we have to discuss about the repetition, right? An algorithm to display a number from 1 to 10. So step 1, start. Step 2, declare a variable I, declare the variable I. Step 3, initialize a variable I equal to 1. We have to display the value 1 to 10. We are initializing value I equal to 10. Repeat until the I is less than or equal to 10. Until the value is I is less than or equal to 10. 1 less than or equal to 10. The condition is true. So display I will get displayed. I is I become I plus 1. So I's value is 2. So 2 less than 10, 2 will get displayed. Then I is become 3 here. Then 3 will get displayed, and 4, 5, 6, 7, 8, 9, 10 until 10. 10 means 10 less than or equal to means it's also true. 10 will get displayed. I equal to I plus 1 means 11. I is become 11. Now the condition is false. It will come out of the end repeat loop. So the values from 1 to 10 will get displayed. Okay. So this is the part 1 of the algorithm. So we will discuss more example and as well as pseudocode in the part 2 in the forthcoming video. So thanks for watching the video.